This is the Chapter 9 review for Thursday's test. So this is about transformations. First one says, what are the coordinates of the image after the given transformations? So right here, we start with negative 10, 5, rotating 90 degrees. If you're going clockwise 90 degrees, it's y comma negative x. If it's counterclockwise, it would be negative yx. For the rest of these problems, I'm going to assume it's clockwise, but on the test, it will specify. So if it says clockwise 90, you'd get the x value, change the sign, and then flip it around. So it's going to be a 5 first, and then a positive 10. And that's if it's clockwise. If it's counterclockwise, you're going to change the sign of the y value and flip it around. So it's going to be a negative 5, and the 10 is going to stay negative. And that's for counterclockwise. For reflecting across the y-axis, the rule is change the sign of the x value. That's it. So since negative 0 is still 0, it's going to continue to stay the same. So A prime would be the same coordinate. For number 3, if you have 7, 2 and you're rotating 180 degrees, you're supposed to change the signs of the x and the y. So for A prime, you'd have negative 7, negative 2. Then for the next one, this translation, sliding it around, you're going to go 7 to the left and 2 down. So for A prime, 24 minus 7. And for the y, it'd be negative 34 minus 2. 24 minus 7. I haven't had enough coffee to do that in my head, so I'm going to use a calculator. 17. And then negative 34 and negative 2. Negative 36. Notice, I'm showing what the formula is supposed to be, and I'm showing the answer. Over here, there's actually some work to show, so I'm showing that work. So that's what you'd be showing on the scratch paper that you'd be sending. This one says translate 2 to the right and 4 up first. So if you go up, oh, sorry, that says 2, yeah, 2 to the right, 4 up. So 2 to the right, 1, 2, then 4 up, 1, 2, 3, 4. This would be your A prime. For B, you can do the same thing, 2 to the right, 1, 2, 3, 4 up. That's B prime. For C, 2 to the right, 1, 2, 3, 4 up. There's C prime. I connect that to make that little triangle. That's translated. And then reflecting across the y-axis, you can actually see the y-axis because it's a graph. You can use the formula, but you don't really need to because it's the same distance in the other direction. So C prime, C double prime would be here. And then for B, 1, 2, 3, 4, 5 spaces. So 1, 2, 3, 4, 5 spaces. There's B prime. And then for A prime, 1, 2, 3, 4, 5 spaces. So 1, 2, 3, 4, 5 spaces. And that would be A and then double prime. So that means your final answer would be this triangle right here. Number 6 says first rotate clockwise 90 degrees. So rotating clockwise 90 is going to be down in here. The rule is y negative x. So if you find this coordinate is 2 and then up 3. So A is 2, 3. Then A prime, you change the sign of the x value and put it second, then the y value would stay the same and it'd be 3, -2. So 1, 2, 3, down 2, and that would be your A prime. You could do the same thing with B. So this coordinate, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So B is 6, 7. B prime. Would be for clockwise 90, the x value changes, so it'd be negative and then be over here, and then the y value moves to the front. So 7, -6, 1, 2, 3, 4, 5, 6, 7, then 1, 2, 3, 4, 5, 6. That'd be B prime. Now it says reflect y equals x. So y equals x would be a line that goes like that. That formula is just the y and the x are going to trade places. So if you already have a prime is 3, -2, a double prime would be -2, 3. So -2, 1, 2, 3. Then for b prime, trading those places, you'd have -6 and then the 7. So -1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7. And you're right here for B double prime. And that segment goes this way. And that's mirrored across this line. For number 7, it says translate -5, 7. So that means 5 to the left and 7 up. If we get A, 1, 2, 3, 4, 5, up, 1, 2, 3, 4, 5, 6, 7. There's A prime. For B, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. There's B prime. And then for C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And that would be C prime. So we got this triangle here. And then it says reflect across the x-axis. So x-axis is the horizontal line. That one you can use the formula, but you can also just go straight across. So 1, 2, 3, 4. Go 4 the other direction. 1, 2, 3, 4. That's going to be your A double prime. For B, same thing. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Here's B double prime. And then for C, 1, 2, 3, 4. So we go 1, 2, 3, 4. And there is C double prime. So your final answer would be this little triangle right here. Number 8 says describe the transformation. So if you look from here, this is your original, your pre-image. Then the first image you got is over here. B is staying on top and A is staying on top, so it's translated, slid across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now that I know it's 10 spaces to the right, it'd be translated, and you can put it with a little bracket like that. And it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right, because it's pre-image to image, so 10 to the right is positive. and then we didn't go up or down. So it could be written like that for the translation, or it could be written x plus 10, and then just y stays y. We'd be adding 0 to it. So that's the first piece of it. And then the second thing that happened was it came straight across this line. So this is your x-axis. So this is reflected across the x-axis. And the rule for translating across the x-axis, x comma negative y. So this is translated right 10 spaces and then reflected across the x-axis. Over here, we're starting on the first quadrant, and then it went to the second quadrant. And if you look, it rotated counterclockwise, and it went from one quadrant to the other, so that's 90 degrees. So first it went counterclockwise 90 degrees. After that, this is staying the same direction. It just slid or translated. So after that, translated. And this is going, if you go from A to A, 1, 2, 3 spaces to the right. And then after it goes 3 spaces to the right, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces down. So counterclockwise 90, y negative x, and then translated 3 right and 9 down. Too early. This is left. I'm sorry. 3 left. I should have put that there. So if you're going 3 to the left, it'd be minus 3. And then 9 down. From here to here left, and then from here to here down. So down would be 9 down, y minus 9. Well, I butchered that one. Apologies. But that would be the answer right there. It started here, rotated 90 degrees counterclockwise, and then from this image, it went to the left 3, and then it went 9 spaces down. Number 10, we don't have the starting graph. We're going to have to put it in. Negative 2, 3, negative 2, 1, 2, 3. That's A. And then B is 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. There's B. And then C, 2, negative 2, 2 to the right, 2 down. There's C. So you've got a triangle. Looks like that. And now it's saying that we're translating it 3 to the right and 6 down. So get every point. 1, 2, 3, 1, 2, 3, 4, 5, 6. There's B prime. For C, 1, 2, 3, 1, 2, 3, 4, 5, 6. There's C prime. And then A. 1, 2, 3. 1, 2, 3, 4, 5, 6. And that would be your C prime. And that triangle goes like this. Number 11. This has it where you're going across x equals negative 2. And because we're doing distance learning, we're not doing that. So This problem, the way it's written, would not be on the test. I'm going to fix it so that we have another good example. And I'm just going to take off this piece. And we're going to go across the x-axis because that's as close as we can get to what we did in class. So -8, -4, -8, 3, 4, 5, 6, 7, 8, right here. Oops. -4, 1, 2, 3, 4. So this is actually the point A. And then for B, -2, 8, -2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then for C, so that's B right there. C, -6, 2. 1, 2, 3, 4, 5, 6. And then up 2. That is a terrible triangle. -8, -4. That's A. And then -2, +8. That's B. And then -6, 2. That's C. That is a terrible. Oh my goodness. Well, it is what it is, I guess. All right. Well, that is a really bad example. Oops, I went the wrong way. Man, it's supposed to be down here. And then this way. Still, that is a horrible, nasty. All right, reflecting across the x-axis. I'm gonna use a different color to make it easier to see. X-axis is this line from left to right. So B would be 1, 2, 3, 4, 5, 6, 7, 8 spaces. Go down 8. 1, 2, 3, 4, 5, 6, 7, 8. This would be B prime. For A, it was on the bottom, so it'd go up 1, 2, 3, 4. So go up 4 more. 1, 2, 3, 4. And that would be your A prime. And then C was right here in all this mess, but it was on top of the x-axis. So down 2, go down 2 more. And that would be your C prime. And you would have this terrible triangle reflected across the x-axis. Yuck. All right, backside. So it's asking if you have a line of symmetry for 12, 13, and 14. So on this one, you can go right down the center of the triangle from top to bottom. So that'd be a yes. For the rectangle, you could go straight down the center this way. You could also go straight down the center horizontally. So yes. This one, there's no real line that you could make where you could mirror it across. So this one's a no. Number 15. It's asking if you have rotational symmetry, and if yes, the order. Remember, that's the number of times that you could, as you're spinning it, get the same image. It would look exactly the same. No one would notice that you moved it along the rotation. So you have the original, and if you rotate this around 180 degrees, you would come out with another one. So that means that your order is 2. And when it comes to your magnitude, 360 divided by the order would be 180. So if you notice, that's the only work that you need to show on this problem on your scratch paper, is just how you got your magnitude. For this one, there's no way that you could rotate that and get anything else until you got right back to the beginning where you started. And this is a 6-pointed star, which means that every time that you go over, you rotate it 1/6 of a turn, it'll look the same again. So that means your order is 6. For your magnitude, take 360 and divide it by that 6. So your magnitude, I'm going to put MAG for magnitude, would be 60 degrees. Every 60 degrees, it's going to look like you never moved it. Number 18, Marco says the circle has infinite lines of symmetry. Jane says a circle has 0 lines of symmetry. Who's correct? Well, Jane makes an interesting point because it would almost look like it's always the same and it's just one circle. But Marcos is right because a circle has an infinite number of points. Like we label it and say, oh, we have a point A and a point B and a point C and a point D, but really there's an infinite number. So that means that as you rotated it, it always looks the same. Technically, Marco is right because there are an infinite number of points on a circle, and any amount of rotation makes a congruent circle. This is not a question that I'm going to ask on a test, but it is a question that makes you think about how rotation works. So don't worry too much about it. All right. Elizabeth and Monica are each reflecting their graphs across y equals x. Who is correct? So remember the line y equals x goes like that. So if you imagine that's the mirror, Elizabeth is the one who's right. And if you needed to explain it, if you have to give a reason to prove that you are correct, one way that you could do it is grabbing those coordinates and using the rule for reflecting across y equals x, which is y x. Number 20 says if you translate the points 4, 7, and 5, 10 by -6, -4, and then rotate it, and we're assuming that's clockwise, what are the coordinates of the image? So we're going to do 1 point at a time. If A starts out 4, 7, and you're going to subtract 6 from the x value, 4 minus 6 is -2, and then you get that 7 and you subtract 4, you're at 3. Then when you rotate 90 degrees clockwise for A double prime, you're going to change the sign of the x value. So it's going to be a +2, and it's going to trade places. For B prime, you can do the same process. So if you subtract 6 from the x value, 5 minus 6, -1. And then if you subtract 4 from the y value, 10 minus 4, you're at 6. Then when you rotate 90 degrees clockwise, remember it's change the sign of the x and move it to the back. So this 6 comes up here to the front. And then this would be your coordinates. So I'm showing what's the formula for both of these. I'm showing my first image and then my final image. So that's the work that I'm showing for that problem. Number 21, once again, we didn't get a chance to get into going off of the origin. So we always rotated from the center of the graph. 3, 4 would be a different point. We're not doing that because of the distance learning. So I'm going to take that part off so I can still show you an example of something that would be on the test. So if it's rotated 90 degrees, and we're going to assume that's clockwise, the rule for rotating clockwise is y comma -x. Or you can get your graph, and if you know that you're rotating 90 degrees clockwise, you're going to go this way. If it goes 2 to the left and 1 up, it's going to go 2 up and 1 to the right. Then the next point, 1, 2, 3, 4 to the left and 1 up. So 1, 2, 3, 4 to the right and 4 up and then 1 to the right. So So that's the second point. And then the third one up here, 1, 2 to the right, 1, 2, 3, 4, 5, means you're going to go up to 1, 2, 3, 4, 5, and you're going to be here. So you can do it with the coordinates, or you can do it by figuring it out on the actual graph itself. Next, it says reflect across the y-axis. So the y-axis is this vertical line. You can use the coordinates, or you can count across. So if it's 1, 2, 3, go 3 the other way. 1, 2, 3. Over here, we have to go to the left. So 1, 2, 3. Do that again. 1, 2, 3. Third point's on the right, so get it over to the left. So 1, 2. Go the other way. 1, 2. And now we have the image. Rotating 180 degrees. I'm going to do it the way I did number 21. You can use the coordinates, but you could also just count and go 1, 2, 3, 4, up 2. So do the opposite. 1, 2, 3, 4 left, down 2. For the next point, 2 to the right. 1, 2, 3, 4, 5, 6 up. So we're going to go 2 to the left. 1, 2, 3, 4, 5, 6 down. And then for this last point, 1, 2, 3, 4 to the right. 1, 2, 3, 4, 5, 6, 7, 8. So it was 1, 2, 3, 4, and then 8. We're going to go the other way. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So that'd be rotated 180 degrees. Reflecting across the x-axis. Remember, the x-axis is here. That means that this point would stay here. This point would stay here. And since this is 3 up, we're going to come down 1, 2, 3 to find the image of that final point. And your triangle will be right there.